Alright, this is lesson 415, Constructions with Polygons, part 2, and we're going to be seeing some more constructions, and yes, some more videos within the recording. Okay, today's objectives, we're just going to use technology to draw regular polygons. Our technology right now is YouTube, but I think the lesson is talking about GeoGebra. And you can go through the LMS and check out the GeoGebra activities. Just remember, when it comes to your test, I will expect the constructions to be done by hand. You're going to use a compass and straight edge to construct regular polygons, and you're going to construct an equilateral triangle, a square, and a regular hexagon inscribed in a circle. Some of the key terms we're going to be using are central angle, that's the angle that has its vertex at the center of a figure. A regular hexagon, a six-sided polygon that is equilateral and equiangular. Now let's talk about constructions. A circle is a helpful tool when you create constructions. With circles or arcs, and usually what we see is arcs, you can mark equivalent lengths, which is handy when constructing polygons. What you're going to need is pencil, paper, a compass, and a straight edge to try each of the constructions. Now then, this is a pencil, okay? I bet y'all know that. This is just a representation of paper. This is a compass. I have many students who think a compass is a protractor. A protractor measures the angles. A compass creates an angle, okay? So do not use a protractor unless you're using it as a straight edge or comparing and making sure your constructed angles are the same size, okay? When you're creating a construction, you always use a compass, and of course there's a straight edge. And you received a compass and a straight edge in your K-12 supplies. Okay, the first thing we're going to do is watch a video on constructing an equilateral triangle. Now remember, equilateral triangle means that all three sides of the triangle are congruent and all the angles are congruent. Okay, that's what equilateral is. Now then, in the construction we're creating, in the LMS, it shows that all three sides of the triangle are radii of congruent circles, so all three sides have the same length. Now, I may pause during the video because I think in the video they just use arcs. They don't use full circles. So I may pause the video and talk to you about it a second. I can't remember if I needed to do that or not. Okay, let's go ahead and watch the video.
Hey, here we are back in Unit 6 review. We're constructing an equilateral triangle. To construct the equilateral triangle, this is a very quick construction. You just need to take your compass and make sure you open it up to the length of the given segment that they ask you to construct the equilateral triangle to. And from this endpoint, I'm going to strike an arc that comes out. You can do this on either side. Just since I have some writing up here, I'm drawing it down here. Keeping your compass at the same length.
Okay, now notice this arc that he just drew and made with his compass. Okay, that arc represents a part of a circle. So in the LMS, they may go through and do the whole circle. And the segment that he drew, which is a side of the triangle, would represent the radius of that circle. Okay?
You're going to construct an arc on the other side, and this is basically half of the football.
Okay, that second arc that he did would represent another circle, of which that segment is a radius.
Construction. Where these intersect down here, since we didn't change our compass setting, these are both circles that are congruent, and so their radii, which is the measure of the given segment, are also congruent. So we draw these in. Since we measured this side with our compass and we didn't change the compass setting, all three sides are congruent, creating an equilateral triangle. Thanks for watching.
Okay, let's go on to the next slide. Let me minimize that. Alright, this is constructing a square. Okay, the perpendiculars are diagonals of the square. The circle defines points so that the diagonals are congruent. Any quadrilateral with diagonals that are congruent is a rectangle, and if the diagonals are perpendicular bisectors, then the shape is a rhombus. A shape that is both a rectangular and a rhombus is a square. Now, when you do go through the LMS, they show you how to construct a square using the circles. Okay? So let's watch this video and see what they're going to show us.
Here you can see we have segment AB. I'd like to use my straight edge and compass to construct a square that has all sides that are of length AB. Well, the first thing I need to do is I need to take my straight edge and I need to give myself a nice segment to work from. Now make it plenty long so that you have room to go. Alright, well, I'm going to want to be able to work around on this piece of paper. So let's put A right here. And the first thing I need to do is create the bottom of my square to be the same length as AB. So I'm going to come up here with my compass and I'm going to measure this segment, show my construction mark so that my teacher knows that I measured it. I'm going to come down here and I'm going to put a similar construction mark. And now I can tell myself that this is like B, and so I now have AB. The next thing I need to do is I need to create two lines that are perpendicular to points A and B to create the sides of my square. I'll measure their lengths later on. So in order to do that, I need to create points equidistant from both sides of A. So I'm going to start with A here, and I'm just going to take my compass and put a little construction mark, and same distance over on that side. And now I have 2 points on either side of A, and I can use those points to create that cat's eye construction so that I have my perpendicular. So I'm going to go down below and come up, keep that same measurement, come over here to that other point that's equidistant, come below, make that nice mark. And now what I can do is use my straight edge. I'm going to go through those points of intersection, just like so. Make this plenty long, and I now know that this meets at a right angle. Well, now, because I'm working with two compasses, I was able to leave this compass, as you can see, set to the length of AB. So I'm going to come back here to A, and I'm going to mark how long AB would be. So this is not what we would normally do, right? I wouldn't call 2 points B, but just to help you see that this segment AB and this segment AB are the same length, I'm going to go ahead and call it B, just again for that visual. Now, we need to create another perpendicular over here at B. So do you remember what we did? We took our compass, and the first thing we needed to do was to create 2 points on either side of B that were equidistant. So there's a point. I keep the same setting. Come over here, another construction mark, and now these 2 points of intersection are equidistant from B. I'm going to do that cat's eye construction. So here I go, my point, open it more than halfway, start below, come up and make a nice arc, keep the same setting. I'm going to come over here to this point that was equidistant from B, draw the other half of my cat's eye, there we go. Now I'm going to take my straight edge and my writing tool, and I'm going to line up those wonderful intersection points. I'm going to draw again a very nice straight segment. This creates a right angle. So now I've got to measure this segment to again be the length of AB. Again, I'll go back to my other compass. I haven't changed the setting, but let me prove that to you. See how it's the length of AB. So now I'm going to come down here to this B, put in that construction mark, Well, since I'm calling this B, how about I come up here and tell you that this is A. And again, I wouldn't really call 2 points the same name in a picture, but I'm doing it to show you that now this segment is of length AB, this segment is of length AB, and this segment is of length AB. Now the cool thing is, because I have these right angles, and I know that these lengths are congruent, I can go ahead and just take my straight edge and connect these 2 points of intersection, which I made from my construction marks before, and I now know that this segment is also of length AB, and I know that these are 90-degree angles, and I have just made a square who has all sides of length AB.
Okay. And you could see where she was drawing arcs. Just imagine all those arcs are parts of a circle. So if she had done circles, her construction would have looked similar to what I have here on the screen. Now then, yes, I used PowerPoint to create this. You cannot do that if you have to construct a square for me. Okay? I need you to actually use a compass and a straight edge. No computers. Okay. Oh, I said up at the top that we're constructing a square, and we're not. We are actually constructing a hexagon in this one. Now, if you look at all three of these circles and what I've put together here, and I don't even know if they're the same size, but it looks like in the pictures they all have the same radius. Okay, all of their radii are congruent. So each side of the figure is the base of an equilateral triangle. So if you were to take this vertice and connect it to this center, you would have an equilateral triangle. You're going to have one right here as well. Okay, and you can go around and you'll end up with 6 equilateral triangles. This means that all the sides have the same length and each interior angle measures 120. So let's watch this YouTube video and see how you actually construct a hexagon using a compass, pencil, and paper.
Alright, in this construction we're going to learn how to construct a regular hexagon. If you remember a regular hexagon, the radius of the hexagon is congruent to the side length of the hexagon. So all we have to do is take a circle of any radius. Alright, so I need to draw a circle here. Alright, so this is going to also be the length of my side. So I can place any point on my circle and walk my compass around the edge, making 6 congruent markings. Now, if you do this very accurately, your last one should land on the one you started with.
Okay, now the way he's constructing this hexagon is using a rotation. And this is actually the way I learned to make a hexagon. But you also need to be reading through the LMS and learn how to create it using the 3 circles like what's behind the video here and that I talked to you about earlier. But doing a rotation is fine. It'll work just as well.
Alright, now we can use our straight edge to connect those 6 dots. And you will end up with a regular hexagon. 1, 2, 3, 4, 5, and last one, 6. Now what you also may notice is that if we connect all of the opposite vertices through the center of our circle, we will also end up with 6 equilateral triangles. So this construction is a dual construction of a regular hexagon and an equilateral triangle.
Okay. And you'll notice he did mention the equilateral triangles in there, and that's the biggie that you need to get from constructing a hexagon. Okay, just to summarize this lesson, you can construct regular polygons by using a compass and straight edge, or you can actually create them using computer software. The constructions for a square and an equilateral triangle are little more than elaborations of the construction of a perpendicular bisector. And it's possible to construct many regular n-gons by drawing a point on a circle and performing a repeated rotation of that point around the center of the circle to find the vertices. And that's what we just saw with the hexagon construction. The angle of rotation is related to the number of sides of the desired n-gon. By following the formula, a rotation is going to equal 360 degrees divided by the number of sides. So, anytime you're going to do a rotation construction, you need to be sure that it's divisible by 360. Okay, after you get finished watching the video of the videos, you need to read through the LMS, complete the student guide, followed by reading the reference guide and adding any additional notes you think you might need for the test, and then complete the following problems in the problem set. And I'm pretty sure these are all constructions that you do need to practice on. Then contact me or attend TOGA if you still have questions or don't understand some of the concepts. And then make note of any general questions you may have when you attend CC. And of course, please add your course and section number with all communication to me, because that helps me help you faster. Thanks for listening.